So, friends, welcome to this lecture series of geomorphology, and today we will discuss about this glacier geomorphology. First of all, we should think why the glacier geomorphology is important for you. See, we have already discussed about these geomorphic agents, the weathering agents. One is your river, then aeolian system is by wind, then we have studied the coastal geomorphology, and this glacier is one of this important geomorphic agent which is mainly working at these higher latitudes and higher altitudes. And glacier, it is, though it is confined to a particular geographic region, but its geomorphic work, like it is erosion and transportation and deposition, it plays a significant role in the geological past. And we know that in the last few million years, starting from this Precambrian to recent, this earth has been many times glaciated and deglaciated, and particularly sometimes the whole earth or this major region of this earth surface was glaciated, and sometimes part of it glaciated and deglaciated. So, we have glacial times and interglacial times, or glacial periods and interglacial periods. In the present time, we are moving through an interglacial period and approaching to the glacial system in geological future. So, now the question arises, if the glaciation and deglaciation occurred in the geological past, we should have evidences for it. Otherwise, talking about this, the earth was glaciated, so it is of no meaning. So that we have that evidences, and we are searching for more and more evidences for determining whether number of glacial and interglacial periods are more or not. So, during glaciation, there is particular types of environment, particular type of depositional environment, erosional environment occur. And if you remember, when we are talking about this initial time of modeling and the initial time introduction to geomorphology, we are talking about this earth surface planeplenation and this geographical change due to glaciation, due to overloading. So, during glaciation, there are overloading occurs on the earth surface, so that there are depressions are formed, and during deglaciations, once this system removed or the glacial removed, this earth, it cannot come or could not come to its original position, so that some depressions are lying still there, and this is called isostatic compensation, or it is under compensation. So, during this glaciation time, this type of topographical changes occur, and during glacial movement, some of this topography are changed, because glacier, though they are restricted to a particular geographic environment, their erosion is at deeper level as compared to other geomorphic agents. Rivers, they erode to certain meters from this earth surface. Aeolian system, they remain there on the surface or near surface, but glacier, as their density is, they say material, it is very heavy. In a glacial body, it is very heavy, glacier mass, it is more. So, its movement, it creates its own channel sometimes, and it is the part of this earth a few meters, it erodes. That means, at a deeper level of erosion, that is characterized by glacial topography or glacial process. Similarly, deposition also, when this glacier melts, it is not able to carry this huge sediment further, so that it deposits the material as moraines. It is the geological terminology, it is called moraines. So, that means there will be depositional topography, there will be erosional topography, and similarly during this movement within that glacial body, this some of these geomorphological features they are occur. So, that has to be covered in this topic. And second thing, that when there is glacier which interacts either with the lake or the ocean, or some of these glacier ice sheets, they are floating on the systems, and these glacier ice, though contain some boulders, pebbles, cover or some sediments, by melting they drop down there and is coming then forming these drop stones. So, that means there are pure glacial environment, glacio-pluvial environment, glacio-aeolian environment. So, different types of environment in combination of glaciers, they form different type of geomorphic features. So, in this class we are going to discuss about how the glacier system forms, how they move, and what is the mechanism of movement, what velocity they move, if they are moving, what are the different topographic changes they occur within their path, and what are the different topographical changes that occur when the glacier melts. So, these type of systems and this type of topographic combinations that will be covered in this present class. So, glacial geomorphology concerns the process by which glaciers shape landscapes and analyze the resulting glaciated landforms. So, glaciers they shape the landscapes, they erode the landscapes, they transport the material from one place to another, they deposit where the glacier melts. So, that the earth surface in particular the higher reaches and higher latitudes. So, they change their topographic due to glacier effect. For example, now if we are confining ourselves in the Indian context, many of these glaciers they are in the Himalayan terrain, they are moving and these glaciers they are the source for these major rivers in India like Ganga, Yamuna, Brahmaputra, Ghagra, Kosi. So, many of these glaciers they are feeding these rivers 24/7 and forming the perennial river systems. And glaciated landforms, that landform means erosional landform, depositional landform. During transportation there are also some landforms are formed that will also be covered in this present class. So, if you analyze this figure here, there are age million years before present. Here if you see maximum part it is glacial, it is interglacial. That means, you see the maximum part of this North American continent that was glaciated about 1 million years back. And now, if you coming that is 2 million years back, there this is interglacial period, only the northern part they are having glaciers. Similarly, if you are going more down, only this part is glaciers. So, that means due to this glaciation and deglaciation in this geological past, many time major part of this landforms, major part of these landscapes has been changed, and this change has been well recorded in the rock record. Now, we say it is stilite or it is dimectite, and mostly they are preserved in the rock record in the sedimentary rocks. Now, if we compare the water budget of this glacier system, of all this water near the surface of the earth, only about 2% is on this land and in the solid stage of the glacier ice. So, here this budget is given 96.5 it is ocean, then other saline water is also 0.9%, but here this 2.5 is fresh water. Out of 2.5 fresh water, it is 68.7% glacier and ice cap, and 30.1% it is groundwater. Then out of this, here if you see ground ice permafrost, that is this much, lake is this much. So, that is this complete water budget of this earth crust. So, we can say here this glacier it only occupies 2% of this land water, 2% of this water, and they are confined in the confined as solid states. So, in the form of glacier ice. Even this negligible percent of this water, this is 2%, this small fraction is sufficient to cover entire one continent, that is Antarctica, and another continent is Greenland in ice, to average thickness of 2.2 kilometer in Antarctica and 1.5 kilometer in Greenland. So, that means this 2% water content in the glacier, it is covering the one entire Antarctica continent, it is covered with ice. Greenland, Iceland, they are covered with ice. Similarly, the ice peaks in this higher reaches like these Himalayas, the Alps, the Andes, so they are also glaciated. At the present time, about 10% of this earth land area is ice covered. In additional, 20% has been ice covered repeatedly during this glaciation of the Pleistocene epoch, much of it as recently as 15,000 to 20,000 years back. So, that means here you see there are glaciations very recent times, that is 15,000 years back to 20,000 years back, we have glaciated surface. So, we have glacier effect very recently. So, this Pleistocene glacial age, it is climate change, Pleistocene glaciation, Pleistocene climate change, we have already discussed in our initial classes when talking about the introduction to geomorphology. So, that we can say very recently the earth was recovered from glaciation and the land surface is exposed. And if you see, when we are talking about this coastal geomorphology also, we are talking that near to the coast in last glaciation time, the sea level was in below 100 meters or so. So, that the entire shelf was exposed and the rivers was debauching their sediments much deeper level as compared to the present. So, that means glacial time most of this water remains in the glaciated form, and so that the ocean level decreases, the sea level decreases and this entire surface is exposed. So, that means it is a geomorphic modification, that means other geomorphic agents they get a chance to work in a wide area as compared to this present. So, that means glacier not only itself affecting the system geomorphic system, it also allowing the other agents to affect very effectively in the exposed surface. Glaciation has been the dominant factor in shaping the present landscape of North American northward and the Ohio and Missouri rivers in the Eurasia northward of a line from this Dublin east end through Berlin and Moscow and beyond the Urals. So, that means I want to say major part of this European system is nowadays also glaciated, and glacier is taking its glacier is working very effectively to change the landscape in that region. In addition, mountains and plateaus in all latitudes has been glaciated to altitude about 1000 to 1500 meter lower than this present snow line. What is snow line? Snow line is an imaginary line here, it is an arbitrary line where below around this line there will be very less melt of the loss of these glaciers. So, here this snow line it changes with time, with climate change, with the seasons. So, here this snow line, suppose for example, this part this is the snow line. So, here the mountains and these higher reaches of these mountains like these Alps, the Himalayas, they are also occupied by glacial ice. Now, we will discuss about geomorphology of glacier surface. Glacier surface here need to understand here, that means once we are forming a glacier, the glacier surface has certain geomorphology, that means it is how is it smooth or it is fractured or it is undulated. If it is so, then why, what are the reason behind it, what is the how this glacier moves within that surface, what is their internal behavior of these glaciers, that is will be discussed in this present point, that is geomorphology of glacier surface. So, the simplest morphologic subdivision of a glacier is to distinguish those that flow between confining rock walls or valley glaciers and those that bury these rocky landscapes and flow unconfined by virtue of their great thickness, these ice caps and ice sheets. So, that means once we say it is glacier, it always comes in your mind that it should be Antarctic like that, it is, that means it is ice sheet. So, ice sheets they also move, but their movement is due to its own weight. So, we are pressurizing it, weight is increasing weight, more and more ice we are adding. So, it will move. In which direction it move? In all direction. So, if you see this plan view, this ice sheet movement, it is of radial in nature, it is moving in all directions. But there are glaciers mostly which are confined in the hilly terrains at the upper reaches, they are called valley glaciers. Why? Because they are confined within this valley. Their confinement within two walls of this valley, that is called valley glaciers. So, this nature of work of ice sheet and valley glaciers are totally different. The ice sheets, they are unconfined, because they are only they are boring out this undulating topographies, but this this valley glaciers, they are confined within the topographic boundaries. So, that valley glaciers, they are restricted movement within that valley, their work is confined within the valley only, but ice sheet, their whole area, the whole entire area will be worked out by this ice sheets. Although the morphology of all glacier is controlled by the heredity of ice, important differences are to be noted whether flow is confined or unconfined. Mostly it is says this heredity, that means this heredity of this glacial mass, that defines this morphology of this glacier surface. However, this either it is a confined system or it is an unconfined system, that defines what type of topography will appear on the glacier surface. Either it is elongated or it will be radial, it will be sheet like, it is moving in a zigzag pattern or moving smoothly, how, at what speed or what velocity it is moving. So, all that depends upon the heredity of the system, and these valley glaciers and this ice sheet, they behave differently. The glaciers originate in regions where snow accumulation exceeds the loss. Here the snow accumulation exceeds the loss and they flow outward or downward to regions where loss exceeds accumulations. Here two contrasting environment. It is forms where this excess snowfall is there or excess mass will be there, then it is loss, and once they move to these regions where loss is more than their accumulations. So, two contrasting environment at the two different end of this glacier system. Here if you see this photograph or this diagram, see this is called accumulation zone. Accumulation zone, here the loss is less as compared to accumulation or the gain, but here it is called ablation zone. Ablation zone means here loss is more as compared to accumulations. So, that means here we are adding the ice mass, and due to its own weight, due to its slope, this ice sheet is moving downward, and here it is coming to a environment where its loss is more as compared to its accumulation. So, that is called ablation zone, that is called accumulation zone. In between there is a line that is called equilibrium line. Equilibrium line, that means it says the loss and gain or the accumulation and loss is compensated. So, that is called equilibrium line. So, the terminus or down glacier extremity represents the line where losses by all causes, that is all causes means by melting, sublimation, erosion and calving into water, collectively term of ablation. So, equal to the rate at which ice can be supplied by accumulation and forward motion. So, here the terminus this end of this glacier is defined in the ablation zone. It is defined by many terminologies by due to it is main work is here that the glacier is losing its strength, it is losing its mass. So, this losing may be due to melting of ice, it may be due to sublimation, it may be due to erosion, it may be due to calving. Calving means detaching sheets of ice, detaching blocks of ice from the main ice body or main glacier body to this water, to this either it is to the ocean or to this lake where this glacier melts. So, that is called calving. So, this is all these terminologies, they are collectively called ablation. So, ablation means loss, that means the glacier mass or the glacier body is losing its strength, it is losing its mass. So, the losing may be due to melting, may be so these are the points through which the glacier lose its ice sheet, ice material, ice mass. In the zone of accumulation, vectors of particle motion are downward into this ice mass as each year snowfall adds a new surface layer to this glacier. Here this point to be understood. At the zone of accumulation, that means we are accumulating ice. So, we are adding one layer with another, one layer with another. So, the movement is downward. So, for example, suppose here earlier this point was here, and after 1 year we are accumulating more ice here. So, that means due to compaction this it is moving here. So, similarly, its one way it is moving also downward. So, in the zone of accumulation, the vector of particle motion are downward into ice mass as each year snowfall adds new surface layer to the glacier. So, here we are moving downward direction, but in the zone of ablation, the zone of loss, vector of particle motion points towards the ice surface, because a surface layer is annually removed, exposing progressively the deeper ice. So, if you see here, the vector is upward, it is system is upward, but here it is downward. So, this is due to addition of ice, annual addition of ice due to annual snowfall. Here due to removal of ice sheets, one layer is removed. So, that deeper level material, deeper level ice is exposed to the surface. So, here net movement is upward, here net movement is downward, the vector, that means the movement of this vector of this movement. So, here if you see this, in this figure it is written the trajectories of particle motion in a valley glacier. The large area of zone of accumulation is not well shown in this longitude across the section. Sections labeled as plus and minus are local areas of compression extending flow. So, here that means the net movement is downward, here the net movement is upward. So, the zone of ablation and zone of accumulation can be distinguished. This is the predominant method of bringing sediment to the surface of this glacier. So, the surface of the glacier, how? Because glacier once it is moving, it is taking the sediments with it and eroding this material. Now, it should be below that glacier, that means at the interface of this glacier and this bedrock, but glacier comes, this sediment comes to the surface, and why it is sediment is coming to the surface? Because of this gradual removal from this ice sheet. So, once at the ablation zone, we are removing the ice from the top level. So, below whatever this sediments was accumulated and it is exposed. So, that the sediment is transported from one place to another and it is exposed to the surface. So, at the cross section of glacier, where up glacier net accumulation and a down glacier net ablation are in exact balance, internal flow vectors are parallel to the glacier surface. So, that means here we can say one is here it is moving downward, here it is moving upward, but here it is parallel. So, that means here this is the three vector ways we can represent the glacier movement. In the zone of accumulation, the vector is pointing downward, the zone of ablation, the vector is pointing upward, and this equilibrium with this vector is parallel to this interface or parallel to this glacier surface. And this is red line, it is the equilibrium line. Here this equilibrium line is here, and this equilibrium zone, you see this vector is parallel to the system. Valley glaciers. So, we will talk about that. We know this we have two types of glacier, one is your valley glacier, another is ice sheet. So, we will talk about these valley glaciers. So, valley glaciers are confined within its valleys. That means, here if you see this photograph, here this is this ice field, this is called ice field, that means it is accumulating ice, and this ice field it is lying somehow this is the contour line, this is the contour line, above this contour, above this particular contour this ice is accumulating, and this is representing the snow line. This is representing the snow line. So, once the glacier field or the ice field, the glacier is accumulated here, due to more and more accumulation its weight increases. So, once this weight is increasing, due to its own weight, the glacier will try to move. Now, what are the pathways to move? So, once the glacier is moving towards different directions, whenever it is getting a valley, it will follow this valley and move to down valley directions. And if you remember, when the last class we were talking something about this valley wall modification and valley size or shape modification, we are talking, the river valleys may be occupied by glacier valleys at certain times. So, the river valleys, as we know, it is of V shape, and once it is occupied by glacier, this valley is modified, the cross section is modified and is converted to U shape. So, this is the evolution of this mountain valley system. So, in a mountainous terrain, the colder temperature and usually higher precipitation at higher altitudes produce ice fields at the heads of this glacier. These are the ice fields, that means these are this background or these are this ground, hunting ground for this glacier to accumulate. So, glacier they are fed ice from these ice fields. As a thumb rule, about 65% area of this valley glacier falls in the zone of ice field. So, here the ice field plays a major role, because to feed a valley glacier we need to continuous supply of ice, otherwise it will that means ablation will occur, this valley glacier will finally it is vanish. So, that means to continuous supply this ice to this valley glacier, this ice fields that plays major role, they continuous supply ice to this ice field to the valley glacier. So, that the valley glacier becomes active and remain active throughout its movement through this valley. So, I think we should stop here, and in the next class we will talk in detail about these valley glaciers, its characteristics, how they move, what are their behavior during movement, and what are these landscapes they form during their movement. Okay. So, thank you very much, we will meet in the next class.